Cheers to the ones that we got. Cheers to the wish you were here, but you're not. Cause the drinks bring back all the memories of everything we've been through. Toast to the ones here today. Toast to the ones that we lost on the way. Cause the drinks bring back all the memories, and the memories bring back you. There's a time that I remember when I didn't know no pain, when I believed in forever and everything stayed the same. Now my heart feels like December.
Hello, good day everyone. Today we are going to discuss the families of chords for the subject differential equation. And proceeding, we have this simple definition for these families of chords in our subject, in which this is an equation having a parameter as well as one or both of the coordinates of a point in a plane may represent a family of curves, and one curve corresponding to each value of the parameter. So since we are considering here the families of curves, so more or less one curve corresponding to each value of the parameter and may represent a family of curves. So it could be a circle, it could be a parabola, it could be an ellipse, and so on and so forth. So when we are going to look into these families of chords, so probably we are going to determine the differential equation of this family of curves in this topic today. So to better understand the concepts of these families of curves involving differential equations, so we need to go into the problem application for us and for you to better understand the differential equation of these families of curves. So we have problem number 1 here, in which we are going to find the differential equation satisfied by the family of parabolas in the figure 1 below, having their vertices at the origin. So take note, their vertices is located in the origin. This one, vertices at the origin and foci on the y-axis. So probably based on this problem, we expect that the family of parabolas are open upward for these positive values, and there are parabolas also open downward for the negative values. So we need to know first the equation of the parabola. So for our solution for this, okay, so solution for this problem, okay, so we have here, okay, so we'll just indicate the x and the y axis. So this could be our x and this could be our y-axis, okay, and this is now our origin at coordinates 0, 0. So vertices at the origin, so meaning if we drew the first parabola here, so we could have this parabola opening upward, okay. So again so let us try to, okay, so more or less this is now our first parabola, and for the parabolas opening downward, so probably more or less they are symmetrical with this parabola opening upward, okay. So this is our first parabola opening upward, and this is another parabola opening downward. So we may opt to draw only 2 parabolas since we have a limited space here. So we can draw the second parabola. So here we have this. Okay, and from here also, more or less, no, we have parabola here. Okay, so we may put this label, no, for this problem. This is now our first parabola, and this could be now our second parabola. And the equation, no, for our parabola, which is opening upward, no, here, if you can still remember from your college algebra and even in your analytic geometry and calculus. So the equation of the parabola here is just simply equal now to x squared is equal now to 4ay. Okay, and for the family of parabolas here, opening downward, so our equation is x squared equal now to negative 4ay. Okay, our figure 1. So from this equation of parabola, we can say that we need to find the differential equation out of this equation of parabola. Okay, so let us assume, no, let us consider C is equal now to our constant 4a, no, when we are considering the x squared equal now to 4ay. Okay, so this equation will then be equal now to x squared equal now to c times y. Okay, so we will assign this one, no, as our equation 1. So after assigning this one, we are going to take the derivative. Okay, let us take now the derivative of equation 1. Okay, so we have here, so let us take the derivative, no. I will assign d is equal now to the derivative of your y with respect to x, which is equal also now to this y prime. So in this case, I'll assign only this variable d, referring to the derivative of your y with respect to x, or simply just the y prime. Okay, so proceeding, the derivative of your x squared is equal now to the derivative of your c times y. Okay, after that one, we need to simplify. The derivative of our x squared is just simply equal now to 2x, and then this 2 minus 1. Okay, is equal now to the derivative of our variable c times, first, no, derivative of your c times your y plus, so this is now a quantity here. Okay, and for the second term, we have here this, since we take the derivative of your c, no, times y, so the next one will be c times the derivative. So simplifying, so we have here 2x is equal now to the derivative of our c, which is constant, so this is just equal now to 0. Okay, so this is just equal to 0. So what remain here is your c times the derivative of your y. Okay, since the derivative, no, is just simply equal now to the derivative of your y is just simply equal now to C d over dx, no, of your variable y. Okay, meaning the derivative of your y is just simply mean that it is the derivative with respect to x of your variable y. You can also write in this form, no, and then this is just simply equal also to this y prime. So that is why c times y prime. So simplifying, 2x is just simply equal now to c times y prime, no. For the information, no, of everybody, this form can also be written as d over dx of your y is just simply equal now to dy over dx, no. So to address, no, some ambiguity or confusion, that the derivative of your y with respect to x is just simply equal to this form, no, dy over dx. So that's why I wrote here c times this dy, in which this is referring now to the derivative of your y, meaning it is just the same of saying that the derivative with respect to x of your y is just simply equal now to derivative of your y. Okay, so simply mean also that this is just equal now to y prime. Okay, c times y prime. So we are going to get the value of your c with respect to the x and y prime. So we can say that your c is just equal now to 2x over y prime. Okay, and we will assign this one as our equation number 2. Okay, so after this one, we are going to substitute, no, this equation to equation 1 to remove the variable c. Okay, so we have here, no, in this part, so substituting equation 2 to equation 1. So we can say that your x squared equal now to c, which is 2x over y prime. Okay, so 2x over y prime times your y. Okay, so the common variable is here, so that would only be 1. So this would be equal now to x equal to 2y over the y prime. Okay, and simplifying, you cross multiply, so x here you cross multiply, since this is just equivalent to 1, no, x over 1, so you can cross multiply, so x times y prime, so x cross multiply x times y prime is equal now to 1 times 2y. Okay, okay, or transposing this one to the other side, so we can actually get, no, the value of our differential equation, no? Or we can actually get the differential equation of this problem number 1. Okay, so transposing this one to the other side, so we can say that this is equal to x y prime minus, no, minus 2y, and this would be now our answer, no, to this problem. X y prime minus 2y is equal now to 0. Okay, so we are going to proceed, no, with another sample problem, our problem number 2. So we have here, find the differential equation of the family of circles in the figure 2. So there's no need for us, no, to depend on the given figure, but we can actually, no, draw this family of circles, no, if their centers, no, are on the y axis. Okay, take note that we need to determine the differential equation of the family of circles having their centers on the y axis. Okay, So we have now this family of circles, and their centers are on the y-axis, and it is not indicated located in the origin. Okay, so for circles, having its center center at the origin will be, I hope you can still remember the equation of a circle having its center at the origin. So our equation for this is x squared plus y squared is equal now to r squared. Okay, this is now the standard. This is actually the standard equation of a circle with center at the origin. But how about if we have a circle where its center is not in the origin? Okay, so what will happen to this equation of circle? Okay, so we are going to write the equation of the circle. The equation of a circle having its center at point, okay, so at point hk. So we will denote this one as our variable h and k, so meaning its coordinates is this one. So we have h and k. Okay, so the equation of a circle having its center at point hk could be this one. Okay, this would be x minus h squared plus y minus k, and then this would be squared is equal now to r squared. Okay, so you can see now the difference of the equation of a circle having its center at the origin, which is just simply equal now to this x squared plus y squared equals to r squared. And for circle having its center at a point hk, meaning its center is not located in the origin, so you could have this equation of circle of x minus h squared plus y minus k raised to the squared is equal now to r squared. Okay, but based on the problem in this one, having their centers on the y-axis, so probably if we are going to draw the figure here, so okay, so let's make this one straight okay, so example, this is now our axis. Okay, and then we need to draw a circle, so probably since their centers on the y-axis, so we can say that maybe one circle is located here. Okay, and then maybe other circles are located at some point in the y-axis. Example here. Okay, it could be a small circle here, and the other circle may be located at some point here. Okay, like that. Okay, as long as their centers on the y-axis, so their centers are on the y-axis, also this one and also this one. Okay, so what equation are we going to use? Okay, so based on this one, for circle having its center at point hk, our h now is referring to this x, to the value of x actually. But in this case, since their centers are located in this y-axis, so meaning our h is just simply equal now to 0. Okay, we only have a value for our k. Okay, so we are going to use this equation of circle because their centers are not located at the origin but at some point in this y-axis or vertical axis. So let us use this equation of circle, but its h value is just simply equal to 0. Okay, so as our solution for this, so we have here this x minus 0 squared plus this y minus k squared is equal now to r squared. Okay, and simplifying this one, so x squared plus y minus k squared is equal now to r squared. Okay, so this is now the equation 1. We are going to use now this equation to solve now this problem. Okay, so proceeding, so we will have a partition here for us to have some space for our calculation. So proceeding from here, taking now we are going to take the derivative. Okay, so again we are going to denote d as our derivative, which is just equal now to dy over dx or equal now to y prime. So we have here derivative of x squared. Okay, so I think we need to erase this one. We have to erase this one, and then proceeding, so derivative of our x squared plus the derivative of our this one y minus k squared. Okay, and then equal now to the derivative of our r squared. Okay, so taking the derivatives of this equation, so we have here 2x. The derivative of x squared is 2x. Okay, 2x, this one is 2 minus 1, and then plus the derivative of this one. Okay, so I hope you can still remember that taking this derivative of this one in this form, that you need to remember in your previous subjects, that the derivative of your u then is just simply equal now to this n, okay, times u, then n minus 1 derivative of your u. Okay, is this y minus k, so this would be 2 times our u, which is y minus k, and then this 2 is n minus 1, so 2 minus 1 times the derivative of this quantity of your y minus k, referring now to this du. Okay, and this is for this term. Okay, equal to the derivative of your r squared. So as you can see, our r here is a number, so that is why it is this r is a constant, so that's why the derivative of a constant is okay. So I'm sorry, so let us erase this one. Okay, so this would be this is our this is a constant, no, our r, which is the radius. Okay, so the derivative of a constant is simply equal to 0. So simplifying, so 2x plus the derivative of this one is, we have 2 times the quantity y minus k. Then the derivative of this one is, the derivative of your y is simply dy over dx, no? Or we can directly say that this is derivative of your y. Okay, so this is the derivative of your y minus the derivative of your k. Okay, so we may assign here this one, no? And then equal to 0. So in this case, our k, no, is a point, no, at some point in this equation. So this is referring now to the coordinates, no, in y. Okay, since our h is related to the x, our k is related to y, so probably this is also derivative of this one is 0, no, since we have a value, no, for this when we have a point there in the circle at this point hk. So simplifying again, so 2x plus this one, 2y minus k, and then the derivative of your y is just simply equal to dy over dx, or we can simply say it is simply y prime. Okay, and then derivative of this one is 0. Okay, so we have this equation here, and then this would be equal now to 2x plus 2y prime times this y minus k is equal to 0. Okay, so proceeding, okay, so this would be actually, no, the 2 is eliminated, no, so we have here this 2x plus we distribute this one, no, plus 2y prime. Okay, and then 2k y prime. Okay, minus 2k y prime is equal now to 0. So we move out, no, these two, so x plus y prime minus k y prime is equal to 0, and these two will be eliminated, no, so this will become x plus y prime minus k y prime is equal to 0. Since we still have this variable k, so it is not yet, no, a differential equation. So we need to eliminate also this k for us to arrive, no, to this differential equation for this family of circles. So we need to get the equation of this variable k in terms of our x, y, and this y prime. Okay, so we transpose this one to this side, so this will be x plus y prime equal now to k y prime. So getting the value of your k is equal now to, we have here x plus y prime over this y prime. Okay, so this would be now our equation number 2. Okay, so we need to substitute, no, we need to substitute this equation 2 to our previous equation, no, to eliminate this value of k. Okay, Substituting this one, no, to equation number 1. So we have here, no, from our previous equation number 1. So we have here this equation number 1, which is x squared. This is just here x squared plus, we have here quantity y minus k squared is equal now to r squared. So this is now our equation number 1. Okay, so we substitute this k here to eliminate the variable k. So we have x squared plus this quantity y minus our k is this x plus y prime over this y prime. Okay, and it is raised now to this squared equal now to r squared. Okay, so taking the derivative again. Okay, so we have here taking derivative, no, again. So we can say that the derivative of our x squared plus this derivative, no, of this quantity, we have y minus this x plus y prime over this y prime is equal now to the derivative of our r squared. So probably our r is constant, so this would be equal to 0, no? And taking the derivative is, we have 2x, and then 2 minus 1 is 1, so this would be 2x plus the derivative of this one, no? So again, we need to simplify first, no? This one here, this inside in this bracket, no? So plus the derivative of, so if we are going to simplify, so we have a common, no, denominator of y prime. So y prime divided by this, actually this is y over 1, so y prime divided by 1 times y. So we have here y times y prime. Okay, minus, we have this minus, no, so y prime divided by y prime is 1 times this quantity here, so this would be x plus y prime. Okay, and then this is again bracket, no, and this is equal now 2x, no, 2x plus the derivative of this quantity here. So if we are going to simplify this one, okay, so we have here y prime, y prime minus, we distribute this negative sign, so minus x, and then negative times positive is negative, so minus y prime. Okay, y prime. Okay, all over this y prime equal now to 0. So as you can see, y prime, and this is minus y prime, so this one will be eliminated, no? So we can only have this equation now, no, after this. So the derivative of your okay, so by the way, no, before we will continue, our equation here is x squared, and then this one, the quantity here is raised to the squared, so we forgot to put a square, no, here. Okay, so we have also a square here, so the result is negative x over y prime. Okay, negative x over y prime. Okay, so we have this squared here equal now to 0. So moving on, we have 2x plus the derivative of our raised to the squared, meaning this negative will be positive, since negative times negative is positive. So this would be equal now to x squared, okay, over this y prime squared, okay, which is equal now to 0. Okay, and then remembering, no, taking a derivative of a fraction. So if you have this derivative of u over b, no, this would be equal now to b derivative of u minus, okay, so let us maybe we are going to move this one, no, if you can still remember, no, taking a derivative of a fraction. So the derivative of your u over b is just simply equal now to b times derivative of your u minus u times the derivative of your b all over your b squared. Okay, so again, b times the derivative of your u minus your u times the derivative of your b all over this b squared. So we can apply it here now, where our u is x squared and our b is our y prime squared. Okay, so proceeding, so we have here this 2x plus, again using this one, our b is this one, the denominator, so y prime squared. Okay, so we have here, let us enclose this one, no, here. So b du, so our b is this one, so we'll have now this fraction here. Okay, so b du, so we have our b is y prime squared. Okay, and then the derivative of our du, our u is x squared. Okay, derivative of x squared minus u derivative of b, so our u is x squared. Okay, x squared times the derivative of our b, in which our b is this y prime raised now to the squared. Okay, all over this b squared, so our b is this one, so we have here y prime raised to the squared, and then it is raised now again to the squared. Okay, so we will enclose this one, and this is equal now to 0. Okay, so proceeding, no, proceeding with our calculation. So from here we have this 2x. Okay, so 2x plus, okay, so again we have a long calculation here, no, so y prime squared, okay, y prime squared, okay, times the derivative of your x squared is simply 2x. Okay, and then minus x squared, okay, minus x squared times the derivative of your y prime raised to the squared. Okay, so again in this case, no, this is y prime raised to the squared, no? In taking up the derivative of this one, so all you need to do is, this would be now your n, no? So 2 times y, this y prime, and then 2 minus 1 times the derivative of your y prime, okay? So we will apply it here. So we have to simplify this one. This would be equal now to 2 y prime, and then the derivative of your first derivative is your y double prime, okay? So we have here 2 y prime times y double prime, okay? And then the denominator is raised to the squared. The square is raised to the squared, so this would be y prime raised now to the fourth, and this is equal now to 0, okay? So proceeding again, so we have 2x plus, so we are only after, no, to this one, a little bit complicated. So again, this would be 2x times y prime squared minus 2x squared, then we have y prime times y double prime, okay, all over y prime raised now to the fourth, and we have here equal to 0. Okay, so 2x y prime squared minus 2x squared y double prime all over this y to the fourth, okay? So after this one, we will simplify. So 2x plus, again, so we let this one, no, having this term divided by this one, so we have to separate this one and this one. So again, we have here 2x y prime squared, no, over this y prime to the fourth, okay, minus this quantity here 2x squared y prime y double prime all over this y prime raised now to the fourth, bracket is equal to 0, okay? And then proceeding 2x plus, so we have here reducing this one, so 2x, and then we have here, so 2 cancel out, so this would be 2, no? So this is y prime squared minus this one, so y prime, so y prime to the fourth, so probably this would be equal now to 2x squared, then y double prime all over this y prime to the fourth, and this is y prime only, so this would be 3, no? Y prime raised now to the cube, bracket is equal to 0. We are almost there, no, for our calculation. So 2x, so we have here 2x, and then we distribute this one, so this would be plus 2x over y prime squared, and then plus and minus, so minus this 2x squared, no, 2x squared y double prime all over this y prime cube is equal now to 0. So if you can observe, no, we have a common variable 2x, no, 2x, and we have also this 2x squared, so we can actually remove, no, we can actually remove these two, no, to move out, no. We have here 2x, we move out this one, so we have 1, so 2x times 1 is 2x plus this 2x over y prime squared, so this would be 1 over y prime squared, no, So we'll just put this one as a bracket, no? Minus 2x squared, so probably this is equal now to 2 x y double prime all over this y prime cube. Okay, and this is 0. So again, this would be eliminated, and we have here this 1 plus this 1 over y prime squared, no? So plus minus this x y double prime over this y prime raised to the cube is equal now to 0. Okay, and we are almost there, no? So please bear now with this solution, and this is just the basics, no, for you to understand the differential equation for this family of circles. Okay, so again, by this we are going to multiply, no, this one as a whole to remove now this fraction. So we are going to multiply this one with y prime to the cube, no, since this is the higher exponent, no, in the denominator. So we can eliminate actually the denominator, no, upon distributing this one to all the terms here. Okay, so y prime to the cube times 1, so probably this is equal now to y prime raised now to the cube, okay, times this one, so y prime to the squared and y prime to the cube, so probably this would be plus, only remain is y prime, no, the y prime. Okay, so we don't have a denominator here, no, so let us erase this one. So y prime plus y prime. Okay, so we have here minus this, this would be eliminated, no, so xy double prime remain. So xy double prime is equal now to multiply this one with 0, so this is now equal now to 0, no. So we start, no, if possible for our differential equation, we start, no, with this highest derivative, no, in which in this case we have this y double prime. So possible make it a positive sign, so we are going to transpose this one to the other side. So we have here, this will be positive, no, so x y double prime, so transposing here, so transpose also this one to other side, so this would be equal now to minus y prime raised now to the cube minus this y prime is equal now to 0, no. So x y double prime minus this one minus y prime to the cube minus this y prime. So I think, no, we have eliminated those constants and variables, and we have obtained, no, this differential equation for this problem. And I think, no, this is it, no, for this differential equation for the family of circle in problem number 2. So x y double prime minus y prime raised to the cube minus y prime is equal now to 0. Okay, so this is it, no, for this problem number 2. Okay, and now I will show you, no, another solution, no, as an alternate solution for this problem. Actually, I'm giving you the basics, no. First, we need to determine the equation number 1, and then after getting the equation number 2 is we are going to substitute, no, equation number 2 to equation number 1. But actually you can proceed directly, no. I can give you this alternate solution for this, no. We have now this alternate solution. Okay, so from our equation 2, if you can still remember, no, in our equation 2, from from our equation number 2. Okay, so we have this formula, no, for our k, which is equal now to x plus y, and then we have now this y prime, no, all over this y prime. Okay, this is our equation number 2. What we did here is we substitute this one to equation 1, but actually as an alternate solution we can proceed directly now in taking the derivative of this equation number 2. So actually we can take the derivative of your k equal now to taking the derivative of your right side, no, which is here. So x plus y prime over this y prime. Okay, so probably our k is constant, so this is just equal to 0, no. So we will this one and then equate this one equal to 0, no. So the derivative of this one is no, from our example, derivative of u over b is just simply equal now to b du minus u db all over this b squared again. Okay, so using this one, so this is our u and this is our b, so we can say that our y prime times the derivative of your, this is our b, no, and derivative of u is this x, no, x plus y prime. Okay, minus this u, this is our u, so again this is x plus y prime, and then derivative of db, so the derivative of our b, so our b is y prime. Okay, y prime all over b squared, so y prime squared. Okay, and this is just equal to 0, no, since this is 0, so we can transpose that one to the other side. Okay, so we have now this one, no, so we take the derivative of this here, and then again, so maybe you are confused with this one, no, so we will proceed, no. So we have here y prime times, so I will just put it bracket here, so we take the derivative of this one, no, so no, we take the derivative now of, we distribute this one, so here we have derivative, no, of your x. Okay, so derivative of your x plus this one, no, derivative of your y prime. Okay, and then y prime times this one, so this is bracket here minus, so we just distribute this derivative, no, derivative of x plus the derivative of your y prime, so minus this one x plus y prime, and then we have now the derivative of your y prime. Okay, all over this y prime squared. Okay, and this is equal to 0. Okay, so again simplifying this one, so we have it here, so we have again, no, we will have this equation, no, so y prime, and then the derivative of your x is just simply equal now to 1. Okay, and then plus the derivative of this one is we will enclose this one with another bracket here, so we have this, the derivative. Okay, so again, okay, so we have here the derivative of this one. No? So first, we have y times the derivative of your we have y times the derivative of your y prime, and then plus this y prime times the derivative of your y. Okay, so we will enclose this one here. Okay, so we have dx, no? Okay, so this is the term, no? This is the term here for this one, the derivative of your y prime. So we will consider this one, no, as for you not to be confused, no? So we have now this parenthesis here. So derivative of x is 1 plus this one, the derivative of this term. So it is enclosed in this bracket here. So y times the derivative of your y prime plus y prime here times the derivative of your y. So again, we are done with this minus. So here we can simplify this one, no? X plus y prime times the derivative of your y prime is your y. Okay, so I think we don't have enough space, no? Okay, so x plus y prime here. So we have here y prime. Derivative of your y prime is y double prime. Okay, and then we have here, okay, so it is equal to 0, and then the denominator is y prime squared. Okay, so proceeding, no, with our calculation. Okay, so we have here y prime times, okay, this one plus, so y times derivative of your y prime, so this would be, again, no, it is enclosed in this bracket, so y double prime, no? So y times the derivative of your y prime, so y double prime, so y times y double prime plus we have here y prime times the derivative of your y prime times the derivative of your y, no? So the derivative of your y is just simply 1, but you are going to differentiate, no, this one implicitly. So that is why we have here y prime, no? So you're going to multiply, no, this y prime times the derivative of your y. So y prime here times the derivative of your y, which is 1, times the derivative of your y, since we are differentiating, no, this variable y, no, implicitly. So that is why y prime times the derivative of your y is 1 times this derivative of y, no, which is the y prime. You can still remember, no, implicit differentiation of this variable y, only for this variable y, since we are differentiating, no, with respect now to x. Okay, so y prime times 1 times this y prime again, so bracket, and we have now this here minus this x plus y y, I think this is y prime, no? Y prime, and then we have this y double prime. So this is double prime all over this y prime squared, which is equal now to 0. Okay, so now we can further simplify this one, no? So we have here y prime, so again y prime times we have here 1 plus okay, we can actually remove now the bracket, no, since their signs are all positive, no? So 1 plus y double prime plus this, so y prime times 1, so this is probably y prime raised now to the squared. Okay, so minus this, actually we can distribute this one, no, here, so this would be x, so we distribute this second derivative, so x y second derivative plus, no, this y prime y prime and y double prime, which is over y prime squared equal now to, so we just equate this one equal to 0, no? So y prime times 1 is y prime, and then for this one plus y prime and y double prime, y prime y double prime plus this one here, so y prime times y prime squared, so probably this is y prime to the cube. Okay, so we have distribute this negative sign, so x y double prime, and then distribute this one here, so unlike sign, so negative, no, y prime, and then y double prime all over this y prime squared. Okay, so if you can observe, no, we have plus y prime, y double prime, and we have also minus y prime, so we can eliminate this one, no, and this one, no. So what remain is this one, so y prime, no, and then this plus this y prime raised now to the cube, and then we have now this minus x y double prime all over this y prime squared. Okay, and this is just equal to 0. So we are almost there, no, and kindly be patient, no, for this calculation, because this is really it, no, for the basic fundamentals for this differential equation, and we are going to proceed, no, in this calculation, because we are almost there to the solution of this problem. Okay, again we are going to simplify, no, so this one will be eliminated, no, since if we are going to cross multiply, so what remain is this one. Okay, so actually this is if you cross multiply, so we can eliminate this one, so our solution for this is y prime plus y prime to the cube minus x y double prime is equal to 0. So transporting this one to the other side, so this would be x y double prime, so this would be positive and this would be negative, no, so minus y prime raised to the cube minus y prime is equal to 0. So if you can observe, no, this is just the same, no, solution, no, for this differential equation as we did, no, in our original solution, substituting equation 2 to equation 1, or you can use this alternate solution to directly get the differential equation for this family of circles having their centers on the y-axis. Okay, so we have this x y double prime minus y prime to the cube minus y prime equal to 0. Okay, so we are there already, no, for the solution of this problem number 2. And now, no, we are going to proceed to our next sample problem, no, problem number 3. Okay, so problem number 3 states that the differential equation, we are going to find the differential equation of the family of chords for straight line. Take note, straight lines passing through the origin. Okay, so for a solution, no, for this one is, I think you are familiar with the equation for a straight line, no? Straight line, even if it is passing through, do you remember, no, for the points law form for a straight line? So it's just simply, no, its equation is y, no, minus y1 equal to m times this x minus x1. Okay, so this is it, no, for a points law form for this straight line having at center, no, at a certain center or at point, no. Sometimes we have its center in the origin or at some point, no, x1 and y1. But in case if your center is located at the origin, so probably your equation will be y minus 0 equal na to m x minus 0, no, or simply your m is just simply equal now to y over x, no. This is y over x, or you can also say that y is equal now to mx if its center is located, no, in the origin, or somewhat it your straight line, no, is passing through the origin. So you can have now this equation for this straight line, y is equal now to mx. Okay, but as you can see, our m is just simply our dy over dx. Okay, okay, so if you can still remember this one, our m, which is now our slope. Okay, this is our slope. Okay, so from this we can say that using this m equal now to dy over dx, so we can have this form here. This one is y equals to mx, so it is dy over dx times x, or we can have this y dx is equal now to x dy. Okay, so y dx is equal now to x dy, or just simply equal now to, if you are going to transform this one, or transpose this one to the other side, so this would be y dx minus x dy is equal to 0. Okay, so actually this is now our answer for this problem number 3. Okay, so this is the differential equation, no, for these straight lines passing through the origin. So we are using this one because our x1 and y1 is just simply equal to 0 because it is passing through the origin. So that's why we are using this y is equal to mx, and where our m is just simply the dy over dx, and then we can arrive the differential equation for this families of plane curves for straight lines passing through the origin. Okay, so this is as simple as this, no? And proceeding, we are going to discuss the problem number 4. Okay, find the differential equation of the family of plane curves for straight lines passing through the fixed point. So we have a fixed point, no, hk, where our h and k are not to be. So we have here at point hk. Okay, so this is again a family of plane curves for a straight line. So again, we are going to use this formula: y minus y1 equals now to m times this quantity x minus x1. Okay, so within this case, our x1 here is simply equal now to our h, no, our h1, and then our y1 is just simply equal now to k1. Okay, or in this case only hk, so we can say that it is just simply as equal to h, no, so our x1 is just equal to h, and our y1 is just simply equal now to k, because this is what is being indicated, no, in this problem, h and k. So since from this equation, no, y minus y1, so probably if it is not being indicated, no, as a fixed hk, so we can assign, no, this x1 equals to h1 and y1 equals to k1, but it is being stated that it is a fixed point hk, so we can replace, no, this h1 equals to h and this k1 is equal to k. Okay, again, so we have m equal now to dy over dx. So again, using this equation, no, actually this is now our, we will assign this one as our equation 1. So from this equation 1, so y minus y1 is equal now to m times x minus x1. Okay, and then proceeding with this one, so we have here this our y1, no, we will have this value of y1 equals to k and x1 here equals to h. So we have y minus y1 is k, no, y minus k equal now to m times this x minus h. Okay, and then this is just equal now to dy over dx times x minus h. Okay, so again, by cross multiplying, so we have now this cross multiplying, no, so y minus k equal now to dy over dx times this x minus h, and then we have now this y minus k dx equal to x minus h times this dy. Okay, or we can simply say, if we are going to transpose this one to the other side, no, so this could be x minus h, okay, times dy Oh, this one, no, we will transpose this one to the other side, no, not this x minus h. So only this y minus k times dx. So x minus h times dy, this would become minus, no, this is minus. Transpose this one to the other side. So y minus k dx is equal now to 0. Or you can have other form, no. If you are going to transpose this one to the other side, you can also have this equation, no. In this case, we transpose this y minus k to the other side, so you can also transpose this to the other side, no, if you want. So you can also have this equation, no, y minus k dx minus this x minus h times dy is equal to 0. So these are just acceptable answers, no, for this differential equation. So you can select, no, either of this equation or this equation below, no. It's just fine. So this would be now our answer, no, for this problem number 4. This is the differential equation, no, for this one, passing through this fixed point hk for these straight lines where our h and k are not to be eliminated, no. So as you can see, our h and k are not being eliminated, no, because that is being asked in the problem. But if it is not being indicated, so you have to go through the solution that I presented, no, in previous problems to eliminate the arbitrary constants, the h and k, and also the r, no, if in case for a circle. So take note, no, just follow what is being asked in the problem. Do not eliminate this h and k if it is not indicated, because though you are doing the correct answer, but if you are not following what is being asked in the problem, so still it is not acceptable, uncounted for as a point, no, if you have some quiz or exam. Okay, so this would be it, no, for this problem number 4. Okay, so maybe this is now our last problem for this day regarding this differential equation again for plane curves of straight lines with slope, no, take note, with slope and x-intercept equal, or with slope and y-intercept equal. Take note, no, case number 1, our slope and x-intercept are equal, and the second case is with slope and y-intercept equal. Okay, so solution for this will be first we are going to determine, no, the slope and x-intercept being equal. We will find the differential equation for that. Okay, so based on the analytic geometry, no, we have these following equations, no, for slope intercept form. I hope you can still remember, no, for this equation for slope and this intercept form for this straight line. So actually we have this equation, no, for this it is just equal now to y equal now to mx plus b. Okay, for our slope and intercept form. So how about if we are dealing with the intercept form only? So how will you do it, no, considering the intercept form? Okay, so again you need to remember this intercept form, no, for this straight line. So intercept form. So probably if you can still remember, no, this equation, x over a plus your y over b is just simply equal now to 1. So this is now our intercept form. So we will denote this one as our equation 1 and this one as our equation 2 here. Okay, and then proceeding now with our solution. So we will have this approach, no, since our for case number 1, no, case number 1. So we have here our m, our slope is equal now to this x-intercept. Okay, so from this one we will have now this from this equation to our a here is just our x-intercept. Okay, and then after that we are going to use, no, from equation 2, so we will have x over a plus this y over b is equal now to 1. So we are after, no, for this b, no, so that we can eliminate this b here and we can arrive now to this differential equation. So that is why we are using first this equation 2, and we are going to get the value of this b in terms of this x, y, and a, and then afterwards we will substitute the b, no, here in equation 1 to get now our differential equation. Okay, so from here we are only after for this b, so we will have this y over b is equal now to 1 minus x over a, or simply our b is equal now to, so we cross multiply, no, so our b is just simply equal now to your y over this 1 minus x over a. Okay, but according to this one, our m is equal to x-intercept, so we can say that your m is just equal now to a, since our a here in this equation 2 is our x-intercept. So we can actually substitute, no, the value of our m equal to a here, so we can say that b is equal now to y over this 1 minus x over m. Okay, which is just equal now to, if we are going to simplify, which is just equal to this this one is m minus x over this m. Okay, since the LCD here is m, so m divided by 1, which is m times 1, so that's why this is m, and m divided by m is 1, so times x, so that is why minus x only. So further we can say that this is just equal to this my over this m minus x, no? So we have now this value, no, of our b in terms of your m, y, and x. So we can actually substitute it here, no? So we have this x, y, and m. Okay, x, y, and m. So probably we can get the differential equation, no, for this. Okay, so proceeding. So we have here, so substituting, so we will consider this one as our equation no, equation 3. Okay, so substituting equation 3 to equation 1. Okay, so y equal now to mx plus our b is this my over this m minus x. Okay, so we are going to multiply this one with m minus x, no, so that we can eliminate, no, the fraction, so that we could have a terms which is not which are not a fraction, no. So multiplying y with this m minus x, so we can have this y times m minus x equal to m minus x times mx, so we can have this mx times this m minus x plus we multiply this one with this this one will be cancelled, no, so plus m y. Okay, so distributing this one, so this would be y times m, so my minus y times negative x, so this is xy. Okay, equal now to distribute this one m squared x. Okay, minus mx minus x, so this would be minus m x squared. Okay, plus this my. Okay, so take note, this one is will be cancelled, no, because if we transpose this one to the other, so this will cancel out. So what remains is this one, no, negative xy equal now to m squared x minus mx squared. Okay, so transposing this one to the other side, so we will have now this m squared x minus m x squared plus this xy, which is equal now to 0. Okay, so proceeding, so we will have now this common term here, x, so we can remove, or we can move out this x, no, so we have here x times this m squared, so we move out the x here, so remain is m squared minus, so we move out the x, so mx, no, mx, and then plus xy, so we move out the x plus y. Okay, is equal to 0, so this will be cancelled, no, so this would become m squared minus mx plus your y is equal to 0. Okay, but take note that our m, no, but our m is equal now to dy over dx. Okay, so we can substitute now this m here, so replacing m with this dy over dx, so we can say that this is dy over dx, no, or we can simply say, we can simply assign this one as y prime, no, to shorten this this one. Okay, m is equal to y prime, so we substitute this m equal to y prime here, so it is equal to y prime squared minus mx, so this is no, so this is x, no, x, our m is replaced by y prime, so x y prime plus your y is equal to 0. Okay, so if you're going to transpose this one to the other side, no, So we will have this value here. So y prime squared is equal now to, this would be x y prime, and this would be minus y. So it could be either of these two, no? So you can choose this as your final answer, or you can have this one as your final answer. Okay, so for this one, we have arrived now to this differential equation, no? Y prime squared is equal now to xy prime minus y, or you can opt to have this one, no? Y prime squared minus xy prime plus y equal to 0. So it's also acceptable. Okay, so we are done with our case number 1. Okay, so how about for our case number 2? Okay, so I think we are going to maximize this one, no? For our case number 2. Okay, so case number 2 is with slope and y-intercept equal. Okay, so we have here case number 2. Okay, so based on this one, our m, no, is equal now to the y-intercept. So since our a is the what you call that one, the x-intercept, no, in the intercept form, so our b there is the y-intercept. So m is just equal to b. Okay, so from this equation number 1, so from equation number 1, so we have here y equals to mx plus b. Okay, and from equation number 2, which is the intercept form, so x over a plus y over b is equal to 1. So this is now our x-intercept, but in case number 2, it is said that the slope and y-intercept is equal. So this is now this a is our x, no, intercept, and this b is our y. Okay, so we can proceed, no, with this m is equal now to b using this equation number 1. So proceeding, so we are almost done, no? This would be now our last problem for this day, and we are almost there, no, for the answer. So from this one, from equation 1, so we have here y equals to mx plus b. Okay, and then we have here m is equal to b, so we can substitute, no, mx plus your m. Okay, and then we move out the m, y equals to m, and then this would be x plus 1. Okay, and then since our m is dy over dx, so we can actually have this dy over dx, no, times this x plus 1. Okay, and then cross multiplying, so y dx is equal now to x plus 1 times your dy. Okay, so we transpose this to the other side, no, so we can have now this y dx minus this x plus 1 dy is equal now to 0. Okay, so we already have, no, the differential equation for case number 2, which is this one. Okay, no? With regards to this lecture video, and thank you very much once again for listening, and God bless us all.